Hello everyone, welcome back to Basic Electrical and Electronics Engineering. In this session we are going to discuss what is the relation between phase voltage, line voltage and phase current and line current in case of star connection, three-phase star connection. In the previous session we have already discussed what is meant by phase voltage, line voltage, phase current and line current. Okay, so now let's discuss what is the relation between these two voltages and these two currents in case of star connection. So let's get started. Here we have drawn a star connected network having these three impedances Z ohm and Z ohm. That means it is a three-phase star connected balanced load because all the impedances are same. So we have marked here, this is the neutral point. Okay, these are the supply lines R, Y and B. These are the supply lines R, Y and B. Okay, so the voltage or potential difference between any two supply lines is called as line voltage. Okay, so VRY, VYB and VBR will be line voltages. As it is a balanced load and balanced system, so all the line voltages are equal in magnitude. Okay, so VL equals to VRY equals to VYB equals to VBR. These are line voltages. Okay, now see here, this is the impedance of one phase. This is second phase impedance, this is third phase impedance. So voltage across a single winding or a single phase is called as phase voltage. So this VRN, VYN and VBN are the phase voltages. So let's write here VPH equals to VRN equals to VYN equals to VBN. As it is a balanced load, all the magnitudes of all the phase voltages are same. Now see, we have discussed that the current flowing through supply line is called as line current. So this is supply line, this is also supply line and this is also supply line. So this IR, IY and IB flowing through supply lines are the what? Line currents. IR equals to IY equals to IB. These are the line currents. Now see here, this is current flowing through this impedance, this IY is flowing through this impedance and IB is flowing through this impedance. So and this is from R to N, so we will write I suffix Rn, this is IYN and this will be IBN. So these are the current flowing through each phase impedance. So these are called as phase currents. So IPH equals to IRN equals to IYN equals to IBN. So these are the phase currents, these are line currents, these are phase voltages and these are line voltages. Okay, now see here, from this circuit, observe this IR is the line current flowing through the supply lines. Here also IR is there, here also IR, here also IR is there. That means this line current is same as this phase current because there is no second path available for this current. So this IR is flowing through this winding, this IB is flowing through the same winding and IY is flowing through this IY is flowing from this terminal to this terminal. That means from observation we can write that IR equals to IRN. This is for R phase. Similarly for Y phase also and B phase also. So IR is what? IL and IRN is IPH. So from observation we can conclude that the line current is equal to phase current in case of star connection. Three-phase star connection. the line current and phase current are same. Okay, this is our first conclusion. We have got the relation between currents. Now we are going to discuss what is the relation between phase voltage and line current. Typically, the RS phase voltage value is, we are using 230 volt or either 240 volt, and RMS line voltage is either 415 or 440 volt. Okay, if it is 415 or 440 is mentioned, then it is a line voltage. If it is 230 volt, then it is phase voltage. In households, we are using this 230 volt supply, and where we require 3-phase supply, we will get this 440 volt. Okay, so this is the line voltage and this is the phase voltage, and the frequency of phase and line voltage are 50 Hz only. So from diagram we have concluded that line current is equal to phase current. So IL is equal to IPH, and this is important relation we have got in case of star connection. Okay, now let's see what is the relation between phase voltage and line voltage. Okay, for that we have to draw a phasor diagram for this star connection. Okay, for this star connection. So let's draw here. We know that the 3 windings are placed at 180 degrees to each other. So this, suppose this phase voltage V Rn, this Vyn, and this will be Vbn. Okay, these are the phase voltages which are 120 degree to each other. Now we have to draw any one line voltage so that we can get the relation between line voltage and phase voltage. So let's see, we are taking this VRY. Okay, the voltage difference between R and Y. VRY we are going to draw here. So VRY is the voltage across R phase and Y phase. Okay, it is the potential difference between R phase and Y phase. It is denoted as VRY. So it is the difference between R phase voltage minus Y phase voltage. So let's draw here. Where is Vrn? Here Vrn we have this Vyn, but we want minus Vyn. It is positive, then opposite to this with same magnitude we will draw this minus Vyn. So this is our minus Vyn. Okay, we can write it as Vrn plus minus Vyn like this. So Vry equals to Vrn plus minus of Vin is nothing but Vry. So we have this Vrn, we have this minus Vyn, so add graphically. So extend this tip in parallel with this. So we are extending parallel with this. So this is parallel to this. Now extend tip of this phasor in parallel with this. So extending this, where we get this point. So draw from this point to this point, and this is nothing but Vry. This is the phasor for Vry, and from observation we can see that the magnitude of this Vrn is equal to Vyn equal to Vbn. All are same, but and this length indicates the magnitude of voltages. So observe here, as compared to this Vrn phase voltage, the line voltage magnitude is greater. That means Vry is greater than Vrn and Vyn. Magnitude, with respect to magnitude, it is greater. And with the help of parallelogram law, we can find this length because we know this angle. This is 120 degree, this is 120 degree, okay, and this is 120 degree. And this is 180 degree from this positive Yn to negative Yn, 180 degrees there. Out of this 180 degree, this is 120 degree. So this angle will be 60 degree. So with the help of this angle and these magnitudes, by using the parallelogram law, we can easily find the value of this VRY, and we get the value as the VRY equals to √3 times of VRN. √3 times of VRN, that means line voltage is equal to √3 times of phase voltage. So we will get this equation, VL equals to √3 times of VPH. This is the relation between line voltage and phase voltage in case of star connection only. This is valid for star connection only. This phasor diagram is valid for star connection. Okay, so we have got the relation between line voltage and phase voltage also, and line current and phase current also. This is IL is equal to IPH. These are two important relations in case of star connection. Now the three-phase power is given by, we know that power is VI cos phi. AC power is given by voltage into current into cos of angle between voltage and current, cos of phi. So three-phase power will be 3 into VPH into IPH into cos of phi, 3 times single phase power. If it is in case of phase voltage and phase current, if we want this in case of line voltage and line current, then this will be like this. Three-phase power will be √3 times of VLIL cos of phi, where phi is the angle between voltage and current. Okay, this is all about the relation between voltage, phase voltage, line voltage, then phase current and line current in case of star connection. Let's solve one numerical based on it. Okay, we have given here VL is 400 volt, IL is 10 ampere. Find VPH and IPH in case of star connection. That means we have given the line voltage and line current value, and we have to find here phase voltage and phase current value. So we know that for star connection, we have got these two equations. IL is equal to IPH, and second VL is equal to √3 times of VPH. Okay, so let's calculate IPH. So IPH will be what? IPH is equal to, as it is both are same, so IL is 10 ampere, so IPH will be 10 ampere only. Okay, now see here VL is given 400 volt, and this is, we want this VPH, so VPH will be VL divided by √3. √3 goes here, so VL divided by √3, and VL is 400 volt divided by √3 equals to 230.94 volt. Okay, 230.94 volt. This is the phase voltage value 230, when the line voltage is 400 volt. Okay, in this way we can solve the simple numericals for star connection when we have these two equations with us. Okay, this is simple. So this is all about the relationship between different voltages and different current in case of star connection. In the next session we will see the relationship between voltages and currents in case of delta connection. Okay, so till then stay tuned and keep learning. Thank you.